Introduction to the water cycle. The water cycle is a continuous process that describes the movement of water within the Earth's atmosphere, surface, and subsurface. The Sun plays a crucial role in this cycle, driving various processes that facilitate the movement and transformation of water. Understanding the Sun's role helps explain how water circulates through different stages and influences weather and climate. Solar energy and evaporation. The Sun's energy is the primary driver of evaporation, a key stage in the water cycle. When the Sun's rays heat the Earth's surface, water from oceans, lakes, rivers, and other bodies of water absorbs this heat. As water molecules gain energy, they transition from a liquid state to a gaseous state, forming water vapor. This process of evaporation is essential for replenishing the atmosphere with moisture and initiating the water cycle. Formation of clouds. Once water vapor rises into the atmosphere, it cools and condenses to form tiny droplets or ice crystals, depending on the temperature. These droplets cluster together to create clouds. The Sun's heat not only initiates evaporation but also influences cloud formation by determining the temperature and moisture levels in the atmosphere. Cloud formation is a critical step in the water cycle, leading to precipitation. Precipitation and runoff. Clouds eventually become saturated with water, leading to precipitation in the form of rain, snow, sleet, or hail. The Sun's energy affects the amount and intensity of precipitation by influencing temperature and humidity levels. Precipitation then falls to the Earth's surface, where it can either infiltrate the soil, replenish groundwater, or flow overland as runoff, eventually returning to oceans and lakes to continue the cycle. Role in transpiration. In addition to direct evaporation from bodies of water, the Sun plays a role in transpiration, the process through which plants release water vapor into the atmosphere. During photosynthesis, plants absorb water from the soil and release it through small openings in their leaves called stomata. The Sun's energy facilitates this process by warming the environment and increasing the rate of transpiration, contributing to atmospheric moisture. Influence on weather patterns. The Sun's heat and energy drive weather patterns and climate, which in turn affect the water cycle. For example, regions with high solar energy receive more intense evaporation and precipitation, influencing local weather and climate conditions. Conversely, areas with less solar energy may experience lower evaporation rates and reduced precipitation. The Sun's role in creating temperature gradients and atmospheric circulation patterns is crucial for understanding regional and global water cycles. Impact on seasonal changes. The Sun's position relative to the Earth changes with the seasons, influencing the water cycle in different ways. During warmer seasons, increased solar energy leads to higher evaporation rates and more frequent precipitation. Conversely, in cooler seasons, reduced solar energy results in lower evaporation rates and potentially different precipitation patterns, such as snow or ice. Seasonal variations in solar energy contribute to the dynamic nature of the water cycle throughout the year. Interaction with climate systems. The Sun's energy interacts with various climate systems, such as ocean currents and atmospheric circulation, which influence the water cycle on a global scale. For example, warm ocean currents can increase evaporation rates and affect regional weather patterns, while changes in atmospheric circulation can impact precipitation distribution. Understanding these interactions is essential for predicting and managing water resources and climate-related challenges. Conclusion. The Sun is a fundamental driver of the water cycle, influencing processes such as evaporation, cloud formation, and precipitation. Its energy affects weather patterns, seasonal changes, and climate systems, all of which play a role in the continuous movement and transformation of water. Recognizing the Sun's role in the water cycle helps us understand the intricate connections between solar energy, atmospheric processes, and the Earth's hydrological systems.